to the next problem from Blind75 Leetcode, which is merge two sorted list. Here list is a linked list. So let's take a look at the problem. You are given the heads of two sorted linked lists, list 1 and list 2. You have to keep note that those two are sorted linked list. And we are given heads of the each linked list. Merge the two linked list in a one sorted list. This list should be made by splicing together the nodes of the first and the first two lists. Return the head of the merged linked list. So if you look at these two, how we will merge it. So we'll look at the sorry the heads of each of the list. They are equal, so we'll take the first one and we will move to the, say we took this one and we move to the second, the next node, which is 3 here. So we are at 1 and 3 here. Which one is smaller? 1. So we add it as the next pointer and then we move it to the next one. Then now we are at 2 and 3. And which one is smaller? 2. So we add that and we move towards the next one and so on. So this is exactly similar how we would do it for a normal list. So this is just that it's a linked list, you need to link it together instead of doing it. For example, say what if it was a small list? How we will implement this? So I am taking the same example given here, 1 2 4 and 1 3 4. So we'll start from this head and this head. We'll take, since it is equal, we'll take one of the element. Suppose we take the suppose this is L1 and this is L2. So we took the L2 and we moved to here. Now what we have is 1 and 3. Which one is smaller? 1. So we add 1. If it is a list, I meant. Okay, so now we are at 2 and 3. Which one is smaller? 2. So we add 2. Then we move to here. 3 and 4. Which one is smaller? 3. Then we move here. 4 and 4. So we add one of it and one of it. So this is how we would normally do, right? There is no difference. This is how we are going to do. Instead of adding it to a list, we will keep linking this. That's it. That is the only difference here. So what would be the complexity here? Suppose we had a so let's look at the constraints. Yeah, so the maximum length can be 50, but it can also be 0, right? Inclusive. So maybe L1 is 0, maybe L2 is 0, that can also happen, and the maximum length is 50. So the length is not equal, right? And each of the value would range from minus 100 to 100. So it can be either minus 100 or minus 99 or up to 99 or 100, the value. They are already sorted, so we don't, so this list is sorted and this list is sorted, right? So let's see how we can go about it, right? So I'm not specially handling the use case where L1 or L2 can be the length can be 0, because it will be already be done here, right? Or you can add it like this: if not list 1, that means list 1 is empty, return list 2. We don't need to create, right? Similarly, if not list 2, return list 1. So we don't need to merge it because yeah, the other one is 0. So in the same way we would do the comparison and move forward. But we also need to track the head of the new linked list which is created, or the merged linked list head. So for that I'm going to create a dummy node. This is actually dummy, so we will not be using it directly, but we are using it. If you see, this is the example. So list node, I'm going to give any value, -1, and we'll start it with a dummy node. That is because we want a starting point to assign the next to here. This is an easy mechanism to handle the if else cases and do it easily. Okay, so in a while loop we'll do while list 1 and list 2, if list 1 dot value is less than or equal to list2 dot value, what we would do is we would assign that dummy node. So there is this dummy node and we will assign to this. So at the end we know the dummy node, the next node is going to be the head of the new linked list or the merge linked list. That's what we are going to do. So here we are adding, this is the link, then we have to advance link, right? So list1 is equal to list1 dot next. What if it is different? Then what we will do is we will use list2 instead. So list2 is equal to list2 dot next. Okay, so once we are here, we'll keep moving the node is equal to dot next. What if we are using list1 and list2? What if there is for example there is 1, 2 and 3. This is the first one, the next one is say 1 and 2. So it will stop at this condition, right? Both are not equal. So what if this is left? What we'll do is whatever was the last node, we'll just link it to this, and there can be many more, there can be 4, 5, etc. So we just do the linking here. So we need to check if list1 node dot next is equal to list1. We link it with the rest of the list. What if it was list2 instead? Then we link it with the list2, right? So at the end what we would have dummy node which is -1 and 1, 1, 2, I'm just using this as an example, 2 and 3, right? What would be the head of the linked list? It would be the dummy node dot next. So what we will return is return dummy node dot next. Let's see if it passes all the test cases. Yeah, it does. Let's try submitting to see if there is any bug or if we missed something. Done. Okay, so if you look at it, we can do it in a different way as well, right? Can we use the same same method recursively? So we did it iteratively. Can we do it iteratively? Yes, we can. So how do we do it? So we'll keep the same one here. If not list1, return list2. If else if not list2, we'll return this. Then we'll write a condition else if list1 dot value is less than list2 dot value. Same condition, but we are writing it iteratively. What we will do, list1 dot next is equal to, we'll call this method recursively. So the list1 is going to be list1 dot next, list2 is going to be list2, right? What if it is not the other, it's the other way around? So this is, if this is done, we'll return list1. So, okay, in the else case, that means the value of list2 is smaller. So what we will do is list2 dot next is equal to cell dot merge to list of, we will pass list1 and we will do list2 dot next. Okay, what we will return, list2. Okay, yeah, that's it. So we did it iteratively. Here we are doing recursively. Let's take a look. Yeah, this looks right. Let's try running this problem. Yeah, so we did it. Let's try submitting. Okay, so that's it. What is the time complexity here? So we do it for all the elements. So the time complexity here is going to be order of n plus m, where n is the length of one list, m is the length of the other list. And space complexity is also order of n plus m, because we are it doesn't return until the ends of both L1 and L2 has been reached. So n plus m stack frames. Okay, so it is order of n plus m. And in the previous one, So let's see the previous one. Yeah, this one. So what is the time complexity? It is also order of n plus m, and the space complexity is constant because we just use this dummy. So that's it, guys. This is the end of the seventh problem from Blind75 Leetcode list, and I hope you understood the concept and were able to code it. Please let me know if you haven't, or please let me know if you have any feedbacks, comments. Please don't forget to subscribe to the channel. Thank you everyone for watching. See you again with another problem. Thank you. Bye bye.